CAMTECH Gwalior is a multidisciplinary centralized training center under Ministry of Railways. This center develops technical publications, manuals on various railway assets and provides training through seminars and webinars, thereby assisting maintenance team in improving the reliability and efficiency of the system. This video series on maintenance of assets of 132 kV to 27 kV conventional railway traction substation will be useful for field engineers to understand the correct maintenance practices to keep the assets healthy and functioning. In a conventional traction substation, power is received from the grid network of the State Electricity Board or any other power utility at 132 kV. This power is then stepped down to 27 kV through a single-phase step-down traction power transformer, and the power then fed to OHE through various switching and protective devices. This video includes the functioning of traction power transformer and activities as well as testing of traction power transformer to be done at the time of maintenance. The primary winding of traction power transformer is connected to both phases of the incoming lines, and on secondary side, one of the two terminals of the 27 kV winding is connected to OHE through switchgears, while the other is solidly earthed, which in turn is connected to the running traction rails. These traction transformers are available in various rating. Various rating of traction transformers are being used in TSS. The maintenance of traction transformer is carried out in different time period by different schedules. Monthly schedule, half-yearly schedule, annually schedule, 5-yearly schedule, periodic overhauling or POH. In monthly schedule, some the activities to be done like check for crack, dirt deposits and leakage, check for oil level, check for breather, check for maximum temperature of WTI and OTI on day, check for gas collection, functioning of marshalling box, and check for external connections. In half-yearly schedule, some the activities to be done like do all the activity as per monthly schedule, test BDV of oil, do insulation resistance and polarization index test of winding, check functioning of alarm, tripping and PRD devices, and thermography to be done of complete TR. In annually schedule, some the activities to be done like do all the activity as per half-yearly schedule, thermography and tan delta test, check cover gaskets, rod gap setting, and do oil testing such as BDV, acidity and DGA test, check tap changer functioning, relay, alarm contacts, water tightness of box, check thermometer indicator, oil gauge, earth resistance test and check buck holes relay, do voltage ratio test, winding resistance test. In 5-yearly schedule, some the activities to be done like do all the activity as per annually schedule, clean the exposed parts thoroughly and paint as per requirement, check alignment of pipes, inhibitor content of oil, magnetizing current test, winding resistance test, impedance test, periodic overhauling. In periodic overhauling, complete or active parts of transformer to be inspected. Safety precautions. In order to ensure safety of equipment and personnel, some general precautions have to be taken while maintaining the transformer. Ensure that power supply is kept off by opening of circuit breaker and isolation to be done by opening isolators, then provide discharge rods at both ends of equipment under maintenance and discharge any residual charges of equipment. Before starting the maintenance, ensure the use of personal protective equipment for safety such as electrical grade shoes, helmet, etc. There are many activities which has to be performed during maintenance as per schedule, such as check for any signage of defect, leakage, and also clean the following items: tank, radiators, conservator, bushings, oil level indicators and gauge, gaskets of main tank, control and terminal boxes, and fasteners. Check oil level in conservator, tank and bushing. Check breather for silica gel condition and condition of oil in cup. Check arcing rod gap setting of bushing. Check the maximum temperature of the transformer oil on the dial indicator and reset indicator. Check control boxes and terminal boxes cable connections, cover gaskets. Check buck holes relay for any gas accumulation. Check the PRD or explosion vent for any damage and presence of oil. Check functioning of alarm and tripping devices and their circuits. Check the functioning of temperature indicators. Check tightness of connections of HV and LV sides as well as earthing. Once the maintenance activities are done, following tests shall be carried out on the transformer for checking the healthiness of equipment in regular intervals mentioned in the table. Insulation resistance and polarization index test. While performing this test, following precautions should be ensured. Use only certified leads for the test, and lead wires of the mega do not have any joint. Do not apply voltage more than voltage rating of the winding or object under test. Carry out this test in a clean and dry atmosphere. No external lines, lightning arresters, etc. should be connected in circuit. Oil shall be filled completely up to filling level. Make sure that the bushing porcelains are cleaned before testing, since dirt deteriorates the insulation resistance. Insulation resistance and polarization index test of main winding. The main objective of this test is to know the condition of insulation of windings and transformer oil. This is a voltage injection test, and for this test, a 5 kV insulation tester or mega can be used. Steps for testing. Here we are conducting a test for HV to LV plus earthing only. Therefore, for this test, connect both bushings of LV with shorting wire and similarly connect both bushings of HV with shorting wire. After that, connect the LV winding to the earthing. Now connect the line terminal of the tester to HV and the earth terminal of the tester to LV. After that, check all the connections and select the DC voltage level to 5 kV of the tester. Finally, the setup is ready to perform the test. Now, on pressing the test button of the tester, 5 kV DC voltage is applied across HV and LV terminals. As a result, leakage current will flow in the circuit, and the tester will measure this leakage current and calculates the insulation resistance by the ratio of the applied voltage and measured leakage current. Insulation resistance value may be noted from the display. By the same test arrangement, the polarization index test may be performed by measuring the IR value for 600 seconds and 60 seconds, and the PI value is nothing but the ratio of IR values for 600 seconds and 60 seconds. The same test to be conducted for combination of windings as shown in this table. Testing data may be recorded in this format for further investigation and future reference. IR and continuity test of contacts of buck holes relay. This test is used to check the functioning as well as insulation between contacts of buck holes relay. Tan delta and capacitance test. This test shall be carried out on the transformer windings and bushings. This is an AC voltage injection test, and for this test, a 10 kV tan delta kit is used. Tan delta test gives the direct indication of power dissipation in the insulation, that is, it assesses the quality of insulation and any degradation in insulation property can be identified earlier and the preventive action can be taken. Temperature and humidity affects the insulation, so to compare the results at different temperature and humidity and convert the value at 20 degrees Celsius by this formula. Steps for winding testing. Here we are conducting the test for HV to LV only. Therefore, for this test, connect both bushings of LV with shorting wire and similarly connect both bushings of HV with shorting wire. Now connect the HV terminal of tester to HV, red terminal to LV, and earth terminal to equipment earthing. After that, do the interconnections of the HV and control unit of the tester and connect the single-phase 230-volt AC supply to the control unit of the tester. Finally, check the all connections, select the UST/R test mode and choose test voltage up to 10 kV. Now, the setup is ready to perform the test. When we press the test button, up to 10 kV AC voltage is applied to the HV terminal of the transformer. This causes the flow of leakage currents from HV to LV and HV to earthing, but due to the selection of UST/R mode, it will measure the only current which flows between HV to LV and kit calculates the capacitance and dissipation factor or tan delta value between HV to LV winding only. The same test to be conducted for combination of windings as shown in this table. Testing data may be recorded in this format for further investigation and future reference. Steps for bushing testing. This test is to be performed between top terminal and test point or tan delta point of bushing. The bushing and test tap are to be opened properly and cleaned before the commencement of tests. Individual bushing should be tested in a similar manner as the winding tested. Same is also shown in table. Testing data may be recorded in this format for further investigation and future reference. Magnetizing current test. This is an AC voltage test, and for this test variac, voltmeter, multimeter, ammeter or clamp meter are used. This test is very useful to detect defects in the core and inter-turn short circuit in the windings. Steps for testing. For this test, transformer should be at normal tap position and keep the LV winding open circuited. Now connect the variac, voltmeter or multimeter at HV and LV windings respectively and connect a clamp meter or ammeter in HV winding. After that, check all the connections and switch on the single-phase 230-volt AC supply. Finally, setup is ready to perform the test. Now gradually increase the voltage with the help of variac up to 230 volt is applied to HV winding. As LV is opened, so only magnetizing current will flow in the HV winding, which is measured by a clamp meter or ammeter connected. Also record the induced voltage in LV winding. Testing data may be recorded in this format for further investigation and future reference. Voltage ratio test. The ratio test is used to confirm that the winding turn ratio at all taps are consistent with the voltage ratio as shown on the nameplate, and also confirm that the tap changer leads are correctly connected or not. This is an AC voltage test, and to conduct this test, ratio test kit is used. Steps for testing. For this test, LV winding should be open circuited. Now connect the single phase 230 volt AC supply to test kit. and connect HV lead to HV winding and LV lead to LV windings. Also connect the earth terminal to transformer earth. After that, check all the connections and switch on the single-phase AC supply. Now 230-volt AC voltage is injected to HV winding and a voltage induced in LV winding, which is measured by test kit, and calculate the turn ratio and percentage error. Conduct the test for all the taps of transformer. Use these formula to calculate turn ratio and percentage error. Testing data may be recorded in this format for further investigation and future reference. Impedance test. This test is performed to check the deviation from designed percentage impedance at all tap of transformer. This is an AC voltage test, and for this test variac, voltmeter, multimeter, ammeter or clamp meter are used. Steps for testing. For this test, keep the LV winding short-circuited. Now connect the variac, voltmeter or multimeter, and clamp meter or ammeter in HV winding. After that, check all the connections and switch on the single-phase 230-volt AC supply. Finally, setup is ready to perform the test. Now gradually increase the voltage with the help of variac up to 230 volt is applied to HV winding. As LV is kept shorted and current flowing in the HV winding is measured by a clamp meter or ammeter connected. Finally, with the help of measured voltage and current at same side of winding, calculate the impedance and convert it to percentage impedance. With the help of conversion formula of calculate percentage impedance as shown here. Testing data may be recorded in this format for further investigation and future reference. DC winding resistance test. This test can be used to detect internal issues such as shorted turns, burnt or open windings, broken strands, poor connections, and problems associated with tap changers at all the taps. This is a DC current inject test, and transformer winding resistance measurement kit is used to conduct the test. This test shall be last test on winding to avoid DC flux remaining in core resulting erroneous value in the other test. Steps for testing. Here we are conducting the test for HV winding only. Keep the other winding, that is LV winding, open circuited. Connect the single phase 230 volt AC supply to test kit. Connect HV lead to one terminal of HV winding and neutral lead to other terminal of HV winding through clamp. These leads have two circuits, one for current injection and second for voltage measurement, and also connect the earth terminal to transformer earthing. After that, check all the connections and switch on the single-phase 230 volt AC supply and start the test. Here DC current is injected to HV winding and voltage across the same winding, that is, HV winding is measured, and calculate the DC resistance of winding and convert the resistance at 75 degrees Celsius. Use this resistance conversion factor as per IS 2026 for copper winding. Testing data may be recorded in this format for further investigation and future reference. Earth resistance test. Individual electrode or small earth grid. This test is performed for measurement of earth resistance of each electrode and measurement of resistance of entire earthing system when all electrodes are connected to the grid. This is a DC current injection test, and 3-point or 4-point earth tester is used. Steps for testing. For this test, current terminal C1 and potential terminal P1 to be shorted and connect to test electrode. Now connect the second current terminal C2 to earth spikes placed at suitable distance and potential terminal P2 to another earth spikes placed between test electrode and farthest earth spikes. After that, check all the connections and perform the test. In this test, a current is injected between current spike and test electrode and voltage is measured between test electrode and potential spike. Finally, with the help of measured voltage and injected current, earth resistance is calculated. This test method is applied for various grid sizes mentioned in the table. There is another method named slope method to measure the earth resistance of large earth grid. This method is based on resistance measurement at 3 different distances of potential probe from test electrode A and these steps to be followed to perform the test. Table for dP/dC for measured slope mu. Thermography. This activity is very useful to identify hotspot. Image of the complete assembly should be taken by thermovision camera and not of individual subcomponents since the analysis is based on relative temperature of subcomponents and not on ambient temperature. Checking to be done during night time and equipment should be under load. Limit for temperature variation and duration for rectification of issue is given in table. Testing data may be recorded in this format for further investigation and future reference. Oil testing. It is important to understand that transformers oil not only acts as a heat transfer medium but it is also a part of the transformer's insulation system. It is therefore very important to periodically perform tests on the oil to determine the healthiness of the insulating oil, which in turn indicates the healthiness of transformer. Oil sampling procedure. Always take sample oil from bottom drain valve or cock. Fix the sampling tube at bottom drain valve. Drain at least 1 liter oil in a pot to eliminate any contaminations which is accumulated in the drain valve and sampling tube. Rinse the sample bottle with the oil being sampled. Now take sample in the bottle and ensure that sampling bottle is fully filled without any air bubble. After taking the sample, ensure that the valve is correctly closed. Ensure that the sampling is done by an experienced person. Breakdown voltage test (BDV). With this test, the dielectric strength of the insulating oil is tested. This indicates the status of oil contamination or moisture present in the oil. Steps for testing. This test is conducted by placing oil sample between 2 electrodes and AC voltage is applied gradually by not more than by 2 kV per second till the time electrodes have enough potential and starts to conduct through the oil. Total reading to be taken is 6 numbers and BDV is the average of all the 6 readings. Limit value of this test is as per IS 1866/2017 given in table. Moisture or water content test. The moisture in the oil is calculated by using the weight of the moisture by the weight of the oil. The moisture content shall be as low as possible since having more moisture in the oil decreases the insulating dielectric strength and flashovers can happen. Steps for testing. Carl-Fisher titration is conducted in the laboratory and these steps are followed for the test. Limit value of this test is as per IS 1866/2017 given in table. Acidity test. As the name suggests, this test is used to determine the acid content in the oil. New transformer oil generally have no acid content but may develop because of oxidation and contamination. The test is carried out by measuring the amount of potassium hydroxide (KOH) in mg required to neutralize the acid in 1 gram of oil. Steps for testing. This test can also be performed at site through a portable acidity test kit by following these steps. Limit value of this test is as per IS 1866/2017 given in table. Dissolved gas analysis test. In this test, the all sample with all the fault gases dissolved is taken in a sample bottle and sent to lab for analysis, which identifies various gas ppm levels that are present in the insulating oil. Different gases dissolved in the oil indicates different kinds of thermal and electrical stress occurring inside the transformer. Steps for testing. To perform this test in the laboratory, these steps to be followed. Steps for sample injection and vaporization. Steps for separation in the column. Steps for detecting and recording results. Range of gas levels. All concentrations are in ppm. Gas levels for different fault conditions. All concentrations are in ppm.